We have all been told that electric vehicles are completely silent. But if you have ever stood next to one while it accelerates, you know that is not exactly true. Welcome back to Video Tales. The idea that EVs make no noise is an illusion. When you remove the internal combustion engine, you aren't eliminating noise. You are just changing its source. Today, we are diving deep into the electrical and acoustic NVH engineering of electric vehicles. To understand exactly where that sound comes from, and why a quiet cabin is actually an engineer's worst nightmare. First, let's establish the mechanical baseline. A traditional gas engine is basically an air pump running on thousands of controlled explosions per minute. This creates massive amounts of low-frequency vibration, exhaust drone, and mechanical harshness. An electric motor, on the other hand, relies on smooth, continuous rotation. By stripping away the pistons, valves, and exhaust, we drop the mechanical vibrations down to near zero. At low speeds, this makes the vehicle feel entirely silent. But here is the electrical reality. To drive that motor, the inverter has to take DC power from the battery and convert it into AC power. It does this through a process called PWM, or pulse width modulation. The power transistors inside the inverter switch on and off thousands of times per second. This high-frequency switching creates rapidly fluctuating electromagnetic fields. Those fields pull and push on the stator's copper windings, causing them to physically vibrate at that exact switching frequency. That microscopic electromagnetic vibration is exactly what causes the distinct, high-pitched EV whine. So if the motor is quiet, why do engineers struggle with EV cabin noise? It comes down to something called the unmasking effect. In a gas car, the loud, low-frequency rumble of the engine acts like a blanket, masking other noises. Take that engine away, and suddenly, wind buffeting and tire roar become aggressively loud. Even the vac blower motor becomes annoying. To fix this, acoustic NVH engineers have to deploy advanced countermeasures. Like specialized acoustic glass, thicker weather stripping, and heavy sound deadening foam packed into the chassis to isolate the cabin from the outside world. Finally, there is a point where being too quiet is actually dangerous. Below 20 km/h, tire and wind noise are practically zero. To pedestrians and cyclists, a slow-moving EV is effectively invisible. To solve this, regulators mandate the use of AVAS, the Acoustic Vehicle Alerting System. Cars are legally required to broadcast an artificially engineered sound at low speeds through an external speaker. So that spaceship hum you hear in the parking lot? It's entirely synthetic, designed strictly for safety. Ultimately, EVs haven't eliminated noise. They just traded mechanical noise for electrical noise. The silence you experience inside the cabin isn't by accident. It is the result of massive advancements in acoustic engineering. If you found this deep dive helpful, make sure to hit that like button, subscribe, and stay tuned to Video Tales for more high-voltage engineering. Stay safe, and see you in the next one.